Hello, everyone, and welcome back to the discussion about circle as a conic section. So here we're just going to continue this discussion. The overview of this video is we're going to find the standard form of a circle when given the following center and radius. For instance, we have the first problem. We have center, the coordinates are 2 and 7, and then we have a given radius, which is 4 units. So, what would be the standard form of the circle? This is actually useful because in here, we will be learning how to find a standard form when we have a given coordinates of the center, and then we have a given length of a radius, you know? So with that, that's what we're going to do today. So let's proceed. So how are we going to find a standard form for this given? Okay. So first and foremost, we must know the formula. Remember that the formula of a standard form of a circle is what? The square of x minus h plus the square of y minus k is equal to r squared. All we need to do is simple. Just substitute h, k, and r. Yeah, that's it. That's what you're going to do. Just substitute h, k, and r. So for the center, remember that the center is what? Is hk. So basically, what's on the left, that's your h. And what's on the right, that's your k. So with that, we can substitute it there, you know? So here, since we have h as 2, so we will have x minus 2 squared. Then plus, we have y minus your k7 squared. Then here we have the length of radius, which is 4 units, right? So what are we going to do? We're just going to substitute it to the r squared. So we will have 4 squared. So what would be the result then if we're going to square 4? So we will have 16. So let me just copy this one, and that will be your final answer. And that's it. That's how easy it is actually, right? That's it. Now, how about for the second example? Suppose we have a center, 0, -1, and we have, the coordinates of the center is 0, -1, and we have a radius of 6 units. So what are we going to do? The same thing, just substitute it in the formula. Okay, so we have this one. Copy, then paste. Okay, here, remember that your h is on the left side of the coordinates of your center. Remember, okay? So that means your h is 0, your k is -1. So that would be x minus 0 squared plus y minus, we have -1 here, so we will have parenthesis -1. Okay? So if you have minus and then the next term, it would be negative. Don't forget to put parentheses, okay? This is to avoid confusion. Because if you have like for example, y minus -1, this provides a confusion. It's like are you implying that there are two minus signs exist between the two terms, right? So here, if it's -1, despite the fact that the operation sign here is minus, don't forget to put the parenthesis, right? Don't forget to put that. So there we go. So we have quantity y minus quantity -1 squared is equal to, we have your r. So your r here is 6. So just simply substitute it here. If you would notice the parenthesis here, you see this parenthesis, it's let's just say it's not that curvy. It's like that. Why did I put that if you're asking me, just in case? Well, because if there exists a parenthesis inside, like for example, I have let, let's just say I have x minus 1, and then quantity, let's just say 2x plus 4, like that. And then let's just say, like outside, it acts also as a parenthesis. So here, you're going to change the parenthesis and you're going to make it like this. It became like this because inside there exists a parenthesis. So with that being said, the parenthesis outside would be like this. Okay, if ever there would be parenthesis outside and there would be a parenthesis inside, right? So let's go. So we have this one, then what's next? We simplify it. So here we have x minus 0. So what's left if we have x minus 0? So we will have quantity x then squared, raised to 2. So it's just the same as x squared. So as a result, we have what? X squared plus here we have minus negative 1. So if you have minus negative 1, imagine you're multiplying it like negative times negative 1. So negative times negative 1 is positive 1. So you will have y plus 1 squared. And lastly, square 6, you will have 36. And that's your final answer. That's it, guys. That's actually pretty easy, you know. Now we have this one. I do believe that that would be the last problem for this video. All right. So how about this? Find the standard form and the general form of the circle when given the following. So here again, look at the question carefully. Standard form and general form. So that means we're not looking for the standard form, but also the general form. If you know how to find a general form, good for you. If not, I suggest you should watch my previous videos, all right, before you proceed here. Anyway, let's proceed. So, of course, what to do? The easy way is you will just substitute it in this formula. The square of x minus h plus the square of y minus k is equal to r squared. All right. So here's the thing. All right, let's just proceed. I'm gonna explain something later. Okay, so your h is negative 3 and your k is 4 all over 5. So here in this case, if I have h as negative 3, so you know what to do. There must be a parenthesis for negative 3, okay? So we have quantity x minus quantity negative 3 squared, okay? Plus, here we have y minus 4 all over 5. Then is equal to r squared. So the square of 3.5. I was about to say something for this. If you think you can make it as a fraction, like the 3.5 to be particular, then good for you. Okay, I think that would be much better if you're going to make it as a fraction. Okay, so 3.5, can we make it as a fraction? The answer is yes. If you have no idea how to make it a fraction, think of it this way, right? We have, let's just say 0 0.6. You see, 0 0.6 is just the same as 6 all over 10. How do I know that? If I see a decimal, decimal, I mean, a term that has decimal, and then let's just say there are only two numbers between the, I mean, two numbers, and then between them there exists a decimal point, it means that that number, it's been divided by 10, all right? Another example, I have 1.2. So since there exists a decimal point between them, it implies that it's the number here, it's been divided by 10. So this would be 12 all over 10, all right? So that's basically it. So if you have 0 0.6, it implies that 6 is divided by 10. If you have 1.2, it implies that 12 is divided by 10. Okay? In here, it only exists as 6 because you cannot include the 0 here. Okay, you can't include the 0 here on the left side, just 6. Then here, if it's not 0, rather it's 1, just like here in this case, then you include it. So you have 12. So 12 all over 10. All right? So last example, if I have like this, let's just say 3.6. So what does that imply? It implies that I have 36 all over 10. Okay? Then you simplify this fraction. Okay, let's apply it here, right? I have 3.5. So again, it implies that that number is divided by 10. So this this means that instead of 3.5, we can have 35 all over 10. Now here we can simplify this because you see 35 and 10 are both divisible by 5. So 35 divided by 5, that's 7, and 10 divided by 5 is 2. So we have 7 all over 2. So yes, 3.5 units is the same as 7 all over 2 units. And this is much better. Okay? If you can convert it into a fraction, then that would be much better. So we have 7 all over 2 squared. Then we now simplify. Okay, so we have on the left side, right, we have x minus 3 or x minus negative 3. So again, it's like negative times negative 3. So you will have positive 3. So x plus 3 squared. Plus here we have y minus 4 all over 5 squared. Oh yeah, I forgot to put a squared here. That's it. Then here, square 7 all over 2. This would become 49 all over 4. All right? Because here, just have a recall. If you're going to have a fraction, suppose we have a all over b, and there exists an exponent outside, it implies that you have a raised to n all over b raised to n. So that means whatever the value you have outside of the parentheses, you can just simply distribute it on each of the numbers here or each of the side of the fraction. So therefore, you will have, instead of 7 all over 2 squared, you will have 7 squared all over 2 squared. So you have 49 all over 4. Okay? Yeah, so this is your standard form. Okay, standard form. So we're done for standard form, but we're not done for what? Getting the general form. So I'm going to erase this one, all right? Because if I would scroll down, I would have next question, but I do believe that would be for the next video, all right? So I don't want to spoil it, but I think I did. But uh, basically, I don't. Basically, this is the only space I have, so I have to erase the uh, solutions so that we can proceed to the next problem, which is to find the general form of the circle. So let's find the general form of the circle. So here we have the standard form, right? So with that, we can now find the general form through expansion. Okay, meaning there shall never be parentheses. You see this? Parenthesis squared, remove it. Okay. So to conclude, guys, if ever you're told to find a standard form and a general form, you need to find the standard form first before you proceed to the general form. Because without the standard form, you wouldn't able to find the general form of the circle. All right. So with that, let's proceed. So we have to expand this one. So here, it's like you are converting standard form to general form. So if you recall that lesson and we had actually a 1 hour practice for it, what are you going to do? If you're going to convert it into general, you will convert it by what? By expansion, right? But how would you expand them? Like what I mean by expand, you're going to remove this parenthesis squared. So there are two techniques, either FOIL method or algebraic technique. But I would rather do the algebraic technique. So if you don't know the algebraic technique, I suggest you should watch my previous videos about converting standard form to general form and a 1 hour practice video about general form to standard form and standard form to general form. Right? So let's go. So let's expand the square root of x plus 3. What's the expansion of the square of x plus 3? Okay, so there's an algebraic technique. First step is you're going to square the first term. Okay, so the first term is basically on the left side. So we have x, right? So you square x, you will have x squared. So second step. The second step here is 2 times the first term times the second term. So the first term here is what? Again, 3x. Then the second term is 3. So 2 times x times 3. So 2 times x times 3 is 6x. And lastly, we have the third step, which is the square of the second term. So the square of second term is 3. So 3 squared is simply 9. Then you add the results. You will have x squared plus 6x plus 9. All right? Now we will do the same thing for the y minus 4 all over 5. Okay? Since it's a squared binomial, so the same application will do. So, okay, let's find the expansion for y minus 4 all over 5. So square the first term. So square y. So y squared. Next, 2 times the first term, y, times the second term, negative 4 all over 5. Please do not forget the negative sign, okay? Or the negative sign of a number if it's minus, okay? So 2 times y, 2y, times negative 4 all over 5, you will get negative 8 all over 5y. To give you an idea, if you're going to multiply a whole term, like for example, 2 times a fraction, 1 all over 4, you will multiply that whole term to the numerator, not below or both of them. No. Okay, you will multiply it to the numerator. So 2 times y, 2y. 2y times negative 4, negative 8y. Okay, or you can have negative 8 all over 5y. Okay, so that's it. Then what's next? Okay, next is you're going to square the second term. So the square of negative 4 all over 5. So again, if you're going to square a fraction, you can simply distribute the exponent. Okay, so I mean exponent to each side of the fraction. So here you will get what? Okay, we can put the negative sign to 4 or to 5, but for me, I'm going to put it to 4. So negative 4 squared all over negative 5. Not negative actually. No, no, no. All right. 5. Okay, 5 squared. If you're asking me why, like why I would put the negative sign to the 4, okay, it's not that because it's permanently done like that. Actually, when you have negative 4 all over 5, it's just the same as negative 4 all over 5 positively, or you can have positive 4 all over negative 5. So they're just the same, okay? It's just that the main way to do it is the negative sign, it should be beside the fraction. But if you wish to put it on the side to be particular, it could be either to the top, which is negative 4, or below negative 5. But not both, okay? Not both. Because if it's both, like for example, negative 4 all over negative 5, it's like you're canceling negative 1 here, you know? It's like you're dividing two numbers that are negative, all right? Negative 4 divided by negative 5, it's still 4 all over 5. But remember, just like multiplication, if negative divided by negative, you will have positive. All right? So, to answer that question about having negative signs on both, no. I no. It doesn't work that way. All right? So now let's proceed. So here, the square of negative 4 is 16, then square of 5 is 25. Then you add them. So we have plus y squared plus quantity negative 8 all over 5y plus 16 all over 25 is equal to 49 all over 4. Okay? Now we will simplify this one, right? We have positive and negative. Or what to do if we have positive or negative? This would become what? Negative. Okay, just like here, just like what we did here. Where was it? I forgot. Yeah, earlier, right? We substitute negative 3 on the h, right? We have negative negative wait, minus quantity negative 3 if you remember, right? If you remember, right? When we substitute it to the standard form. So negative times negative, it's positive 3, right? So here, just like here, in this case, we have positive and negative. So positive times negative, it's still negative. So as a result, you will have what? Instead of plus negative 8y, you will get minus 8 all over 5y. That's it. Then what's next? You combine all terms on one side. So let me just copy this. And then transpose 49 all over 4 to the left. You will get negative 49 all over 4 is equal to 0. Then we combine similar terms. Now here's the thing. x squared, 6x, y squared, and negative 8 all over negative 8 all over 5y, both of them are lonely. They don't have similar terms. All right? Unlike for constant terms. Because the constant terms, you have 9, 16 all over 25, and negative 49 all over 4. With that, we can combine these three constant numbers. But I think I have to do it quick because I promise that I have to make it shorter, compared to have like having 30 minutes. So, how should I do it? Do I have like calculator here? Wait, for a while. Let me do it quick. Mm. Hold on. Just for a second. Okay. So 9 plus 16 all over 25 minus 49 all over 4. Okay. That will give us an answer of negative 261 all over 100. All right. Negative 261 all over 100 is the answer. But let me copy the other terms first. X squared plus 6x plus y squared minus 8 all over 5y minus 261 all over 100. Then after that, you need to rearrange them from the term that has the highest exponent to the term that has the lowest exponent. So x squared and y squared should be put on the first place. So you have x squared plus y squared. Next are the terms that have a variable like 6x and negative 8 all over 5y. So plus 6x minus 8 all over 5y. All right. Then lastly, the constant term 261 all over 100 is equal to 0. And with that, this is your final answer. Okay, this is your final answer. Okay. Now, you can simplify this. Okay, you can still simplify this general form. Okay, you can still simplify this. All right. Why though? Let's just say you don't want a fraction here. Like you see this denominator 5 and a constant term of 100, and you don't want that. Like you're not a fan of having fractions. You can remove them actually. You can. By how, if you're asking me? Let me just erase this one. So all you need to do is to find the LCD of those given denominators, or sorry, LCD of those given fractions. Right? You have 8 all over 5 and 100, right? Let me put it here. Okay? Yeah, that's the answer, right? So what's the LCD of 5 and 100? All right. So for me, the LCD here of 5 and 100, it's actually 100, right? It's actually 100. All right? Because you see, if I'm going to list all the common multiples of 5, we will have like 5, 10, 15, 20, and so on and so forth. For 100, if we're going to list all the common multiples, we will have 100, 200, 300, and so on and so forth. Now you see 5, right? Assumingly it goes in infinity, there exists a number which is also 100. There exists a 100. All right? And how is it that 100 is one of the multiples of 5? You know? Because you see, 5 times 20 is 100. You know? So therefore, 100 is also a multiple of 5. By the way, what I'm doing here is I list all the multiples of 5 and 100. Okay? So here, with that, we can get the common multiple. So there are actually a lot of common multiple of 5 and 100. In fact, 200 and 300 is also a multiple of 5 because 200 is basically 5 times 40, which is 200, and 300 is basically 5 times 60. But what we're going to do here is we're going to get the least common multiple, like the least one, which is actually 100. All right, 100. Okay, that's the very least common multiple they have. Like that's what do what's that's basically that's what they have in common. at ano, like the very least number. So it's 100. Therefore, we're going to multiply both sides by 100. By the way, if you have no idea how to get LCM or LCD, I suggest you should watch the basics. I suggest you should learn about the basics. All right. So let me just copy this given general form. Okay, put it here, and we will multiply both sides by 100. Okay, we will multiply both sides by 100. So let's start on the left. 100 times 100x squared is 100x squared. Plus 100 times 100y squared is 100y squared. Plus 6 x times 100 is 600x. Am I right? Yeah, 600x. Yeah. Then minus 8 all over 5. So 100 times 8 all over 5. Wait, 100 times 8 all over 5. That would be negative 160. 160. Then minus 100 times negative 261 all over 100. So the 100 here would be cancelled. So you have 261. Then on the right side, 0 times 100 is just simply 0. Therefore, this is your answer. If you multiply both sides by 100. In here, there is no more what? No more fractions. They are all exactly whole numbers, right? No fraction, no decimal, just numbers. And that is all, guys, for today's video. If you would notice, I have, let's just say you're told to find the standard form at least, and you have an endpoints of diameter. How would you do it? And we have also another case. You have a center of a circle, then you have a given endpoint at negative 3, negative 5. Meaning, if this is a circle and there's a center, and there exists a point here which is negative 3, negative 5, how would you find the standard form? We will learn that in the next video. All right? So that is all, guys, for today. Sorry if I talk that fast, and also sorry if my volume of my explanation or volume of my mic is low because I have no proper mic for me to use to talk or to verbally explain what I am doing, especially when it comes to providing solutions. All right, but I hope that you guys will adjust. Right, forgive me for that because I don't have a proper microphone or headset for me to talk that loud. But again, guys, thank you very much, and let's let me just what do you call this one? You know what? Just forget it. I was about to say something, but immediately I already forgot. But point being, guys, uh, that is all, and I hope you have learned something in this video. So, see you soon.